My name is Eltan Grinspus, and I'm Associate Professor of Computer Science here at Columbia Engineering. And I'm also the Director of the Columbia Computer Graphics Group, which is interested in everything to do with visual imagery depicted on the computer. So we were looking at very basic questions about how materials deform in various engineering contexts. Of course, it was clear to us that this has applications in the visual special effects industry and in the animation industry. There are lots of different physical systems that are helpful in storytelling. In computer animation, when you have cartoon-type animated characters, it's nice if they're wearing clothing. And as the artist models the motion or animates the motion of the character in ways that gives expressive gestures, tells a story, talks about surprise, panic, anticipation, it's nice if the clothing that is worn over the character follows the laws of physics, because if it doesn't look realistic at all, it becomes a distraction and we focus on the ways in which it doesn't look real. So by teaming up with the collaborating research scientists at Disney, we developed technologies that allow a computer to plow ahead even during the most challenging scenarios, when there are many layers of tightly packed garments, or when you take a t-shirt and crumple it up and stuff it into a tube. So situations where lots of collisions, all closely knit. And that technology was first used in the film Tangled that was released in 2010 and now exists in the Disney pipeline for use in all the future movies after that. And that technology enabled the heroine in the movie, Rapunzel, to have a much more realistic motion for her dress. Around the time that we were developing technology for simulating the motion of a single strand of hair, we were contacted by a research scientist at Adobe, the company that makes Acrobat and Photoshop and Illustrator. And in 2010, Adobe Photoshop and Adobe Illustrator came out with a new bristle tips paintbrush, which accurately models the interaction of the bristles against the canvas using our technology. We've been teaming up with these wonderful physicists, and some of them are theoretical physicists, others are experimentalists and they work in the lab. And what we bring into the table is computer software that can predict physical motion. Some of the physicists that we're working with are using our software together with their experiments to predict simple problems such as, how does a piece of spaghetti coil as it falls on a table? That seems like a fun and cute problem, but why do you care about spaghetti coiling on the table? Well, first, because it's just basic physics, it's interesting. But second, it turns out that if you can understand how a piece of spaghetti coils when it falls on the table, then you've taken the first step towards laying down transoceanic cables in a way that they don't knot up as they fall on the ocean floor. It's just a long spaghetti falling on a huge table. And if you go from really huge to really tiny, if you can understand how a spaghetti falls on the table, then you can also create stretchable microelectronics, because you can drop tiny little metal wires onto a small microscopic substrate in such a way that it makes a zigzag pattern that allows it to be more stretchy. So understanding these very basic physical systems has impact on things from the very small to the very huge. And it's very exciting for us to be able to develop technologies that are pleasing to the eye, but also helping to advance technology in all these exciting ways.